Welcome to the Teja Statistics. In this class, we are going to discuss about the limits for this Pauli coefficient of skewness and also the Carl Pearson coefficient of skewness. So you can see the formulas here, and the Carl Pearson coefficient of skewness lies between plus or minus 3. So that is minus 3 less than or equals to skp is less than or equals to plus 3. Okay, if you see that the correlation Carl Pearson coefficient of skewness formula is 3 into mean minus median divided by standard deviation. So for that consider skp value is equals to, the mean is denoted by x bar, and the median we are writing here md, and the standard deviation is denoted by sigma. Consider just mean minus median, that is the formula where x bar formula is equals to summation of xi divided by n, and modulus you are considering. So in modulus 1 divided by n summation xi, I run from 1 to n and xi minus median. So that is next we are taking the less than or equals to, we are considering the modulus for xi minus md. So mean deviation is least when it is taken from the median. So it is totally in the formula of the standard deviation. So modulus of x bar minus md is always less than or equals to sigma. So that implies modulus of x bar minus md divided by sigma is less than or equals to 1. So which is our formula? Multiply with 3. So minus 3 less than or equals to 3 into x bar minus median divided by sigma, and less than or equals to 3. So the Carl Pearson coefficient of skewness is always lies between minus 3 to plus 3. Okay. Similarly, the limits for the Pauli coefficient of skewness. Here, the Pauli coefficient of skewness is always lies between minus 1 to plus 1. Okay. The Pauli coefficient of skewness is sk b, that is a formula, that is q3 minus q2 minus q2 minus q1. Okay, divided by, so q3 minus q2 plus q2 minus q1. Let a equals to q3 minus q2 and b equals to q2 minus q1. Therefore the value modulus of x modulus of a minus b is always less than or equals to modulus of a plus b if a and b are is greater than 0. Yes, this is in the formula of the skb value or sk, that is skewness. Okay, modulus of a minus b divided by a plus b less than or equals to, since we are supposing the values of a and b are we can see here. Okay, so a minus b, if you remove the modulus, so it will gives you minus 1 less than or equals to a minus b divided by a plus b plus 1. So the limits of the Pauli coefficient of skewness is always lies between plus or minus 1. Very simple and easiest form. So next, one more example problem for calculate the Carl Pearson coefficient of skewness. So and also Pauli coefficient of skewness to the following data. Here they given the class intervals and the frequency data. So the class intervals are from that we have to calculate the mean and mode and the standard deviation. So here the formulas we are writing first, then we are trying to calculate the formulas. From that formulas we are going to prepare one table. Okay, this is our table. So class intervals are converted into the midpoints, and also the cumulative frequencies for the uh, median, and also all we are doing. Okay, so next, capital N value. So the total of the frequencies, and one more, that is mean is given by that is 56.56, and median we got the value as 56.13. So the mode value from the above data we got as 55.385. Similarly, the quartiles also for the Pauli coefficient of skewness. So that is L1 for the Q1, and Q1 we got 45.875, and Q3 we got as 67.44, like that. And the standard deviation for the above data is 17.83, and Carl Pearson coefficient of skewness, that is mean minus mode divided by standard deviation, that is we got 0.0547, and the Pauli coefficient of skewness 67.44 plus excuse me, and 45.875 minus 2 into 56.13, from that divided by, and 67.44 minus 45.87, we got 0.0486. So almost all both are equal. Okay, so here we have to do the calculation like that, and similar formula and calculation for the Carl Pearson coefficient of skewness. Here the Carl Pearson coefficient of skewness for the following data, that is class intervals and the frequency data again. So mean minus mode divided by standard deviation, and the calculations are also be here, lies in the table. Okay, from that we got the mean value as 6.8, and also the mode value is also be the 6.8. If mean and mode are equal, then the Carl Pearson coefficient of skewness is 0. Okay, we can say that it is 0. The Carl Pearson coefficient of skewness is 0. The standard deviation, if we calculate it, and 0 divided by something is always 0. Okay, you can see for the given data, and also the Pauli coefficient of skewness for the following data, the mean minus mode divided by, and standard deviation is for Carl Pearson, and the Pauli is about the based upon the quartiles they given. So what are the quartiles we have here? So we have the quartile values also. Okay, Q1, Q2, Q3. So no need of doing again the standard deviation here. Just to see the Q1, Q2, Q3 values. Okay. Yes. So you have to prepare the value, that is also be 0.2857 we got. Next, the discussion about the kurtosis. What is the kurtosis value? So this kurtosis value is the convexity of the curve. The convexity of the curve is called the kurtosis. So what is the curve? The curve is nothing but it is denoted if the data is having the normal population, then we can able to draw the graph for that. So kurtosis gives you the convexity of the curve, that is called the peakness in the data, that is where how the data is curve is having, whether it is positive or how much height it is having. Okay, so it is majorly divided into this kurtosis is majorly divided into three types, that is measured on the beta 2 value. What is beta 2? Mu 4 divided by mu 2 square. So if the beta 2 value is greater than 3, then we can say that it is a leptokutric curve. So if the beta 2 is equals to 3, it is mesokutric curve. If the beta 2 value is less than 3, then it is said to be the Platary-Kutric curve, like that. Okay, so you can have the theory part also, and some more theorems are also be there. uh, and we can discuss them in the next session. Thank you.